In this video, we're going to build an MSP430 Nixie tube clock kit. This is an inexpensive 4-digit Nixie tube clock, real Nixie tubes using the Russian tubes. And when I say inexpensive, I mean inexpensive. This one, believe it or not, $48.50 is what the kit costs, and that includes all of the parts. Let's put this one together. Should be a cool one. Okay, what we have is another Nixie tube clock kit to build today. This one's using an IN12A Nixie tubes. These are these type of tubes. As you can see, the display from the front. These are obviously Russian tubes, as you can see from the some numbers on them there. This is a 4-digit clock, and this is actually a very reasonable Nixie tube clock kit. I know a lot of people would like to build Nixie tube clocks, and a lot of people are put off from building them because of the high price. My other one, the one that came from the UK, was several $100s by the time I got it. This kit here is sold on Tindy by a seller whose name is Rob G, and this one here cost me $48.50. So I think, as far as Nixie clock kits go, this is probably the most reasonable one I've ever found. So now that that's out of the way, I'm sure there's probably going to be a lot of people flooding this guy's web store buying this kit, because I like the 6-digit one for sure, but you know what? For the price, you can't beat that one for a real Nixie tube clock, and it also has 0-digit blanking. So let's start by looking at the parts that we have here, and we'll get the parts placed on the board. So it comes as a bag of parts, and the instructions are available online. So here's all our semis and our transistors and ICs. Here's our pins to mount the Nixie tubes, and of course the Nixie tube. I'm going to put this out of the way, as well as the other 4, so that they don't get damaged. And in this bag here, I believe these are the neon, the flashing colon. It's they're not, from the look of the picture, they're not your standard NE2 bulbs. Check these out. Those are the flashing colons for that go in the middle here. Cool, huh? Again, these would be old Russian neon bulbs. We'll put them with the rest of the Nixie tubes, and we'll start by first mounting all of the resistors. And like the last Nixie clock I built, we'll be mounting the pins, will be put on the tubes and then soldered in. That way you'll get the alignment correct. I'm just looking at all the different parts that we've got here, and we'll start with the resistors. I know I've got my camera mounted in a little different location for this video, so it's more overhead. So hopefully you guys will get a bit better view of what I'm actually doing. All right. Now the board itself is not labeled as to, oh yeah, you see it's even got his name on here, by Rob G. So if you want this kit, you have to go to the Tindy website. Now what I will tell you is that he won't ship outside of the United States. I'm in Canada, and I actually had to have this shipped to an address that I have in the United States, and I had to go down and pick it up, because he won't ship outside the States. So for you viewers that are watching from other countries, including Canada, unless you have somebody who can receive it in the States, you're not getting this kit. They won't even allow you, they won't even let you complete the order. So anyway, that aside, as you can see, there's no labeling on the board as to what the parts are, so we have to rely on the documentation. And unfortunately, gotta love it was a nice color picture, but when I printed it, it's a PDF, but of course, PDF prints on black and white. But at least the resistors here are all labeled, so it tells me where they go. So it would be nice to see the color picture because it has all the color codes. But anyway, we'll start by mounting the 47 ohm resistors along the top here and get those 4 ones out of the way. So our 47 ohm resistors are yellow, violet, black, gold, brown. That's because they're 1% resistors, and they will go in these 4 slots up here. So that's the first one's mounted, and next we'll mount the, there's 2 220K resistors, and they go, these 2 over here, those are 220, so let's find the 220s and mount them. So the colors for the 220K are going to be red, black, orange, brown, and there's a total of 3 of them. These 2 here, and there's another one. I'll show you where that is in a minute. Basically, if you don't print up the documentation for this, though, you're not going to be putting it together because, again, it's not silk screened. Only the outline, as you can see, has been silk screened. I'm just going to turn my other light on here. I'm trying to reduce the glare because the problem with putting the camera where it is that I get glare from the overhead lights, which shows up in the picture. If I turn off the overhead lights, then it becomes harder for me to see what I'm doing. So I kind of have to have the lights running. But I'm trying to eliminate or minimize the glare that is picked up by the camera. This light just takes a few minutes to warm up. It's a metal halide, but I think we'll eliminate some of the glare on the board here. Okay, the other on here, the other 220, or sorry, what did I say? 220K. Yes, it goes right down here. That one is a 220. And I mount the 470K resistors. These ones all along here, these are all 470K. So let me find them. 470000, here they are. It's a yellow, violet, black, orange. Because that's your multiplier. You get your first 3 digits, 470, and then 3 zeros is your multiplier. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of them here, so there'll be a few more 470K. Where do they go? Oh yeah, there's another one down here. Okay. And the other one goes right down here next to this diode. That's the 470K right there. So we got all the resistors mounted. Now we'll solder them down. .47K is next. Those ones would be, again, yellow, violet, black, red, brown. .47K are these four here. The first four are these ones that go between the rows of transistors. Now, the difference between this Nixie clock and the last one I built is the way that the tubes are driven. These ones are driven, they're multiplexed by transistors, whereas the other one multiplexed them with a high voltage IC, the same type of IC that would normally be used to drive fluorescent type displays. So these resistors here, actually in the, I guess these are the anode drivers. The other ones were in the cathode drivers. There's the 10 cathodes per tube, and then the 1 anode per tube. So these ones here would be in these 4 transistors. These ones over here on this side, these are going to be the cathode drivers, and these ones over here, these ones are going to be the anode drivers. And just to keep you guys happy, yes, I do have side cutters. They do exactly the same thing as the snips. It just depends on which ones I grab. Okay, the other 47K resistors are distributed among the board. Where do they go? There's 2 more of them here, and they go, it's hard to see here on the board. One appears to be this one right here beside a capacitor. So there's one right there. And the other one goes over next to it, over here. That's the other 47K. Okay, the next ones we'll put on will be the 3.3K. So the colors for that will be the orange, orange, black, brown, brown. That's these ones here. So there's 4 of them along the front here. Now the 3.3 is next to this 470. And there's another one down here next to the diode, at the bottom of the board here. And there's another one down here next to this capacitor. And there's another one right here next to this IC. That's the last of the 3.3K. Okay, and what else is left here? There's a couple more. Let's gotta find the rest of them. I think I got the 47s. Yeah, I got the 47s. What's left? Just a couple of resistors left now. This one here is a 560 ohms. And that goes right over here next to the switches. That's a 560 ohm. And what else? There's one more resistor. And where the heck is it? It's a 0.47 ohm. That's this one here. 0.47 was a black, yellow, violet, silver. 0.47. And that goes down right here in the front. Obviously this is going to be a protection, 0.47 ohm. That's going to be in place like a fusible resistor. That'll be right on the power jack, I'm sure. A lot of devices would use a low ohm resistor instead of actual fuse. They'll use it as a fusible resistor. Okay, that has the resistors mounted. Next we'll mount the diodes. Now there are 4 different types of diodes on this. There's a BAV21, a 1N4763A, a 1N4148, and 3 BAT46. You have to identify them. The number is in very, very fine print on the diode itself. So I'm using my magnifiers just so I can read this thing. And this one here is the BAV21. So that's the first one we'll mount. BAV21 goes I believe it's this one right here. Where are we here? Yeah, BAV21 is this one right here. And the band is indicated, it's facing towards the tubes. Now the diodes are critical. First of all, they're polarity sensitive. If you put them in backwards, you're going to have big problems. But also if you put the wrong diodes in the wrong place, it's not going to work because they have different specifications and different voltages and different speeds and so forth. So you have to get the right diodes in the right place. So that's the first diode. The next diode, which goes right next to that one, which is right here, that's going to be the 1N4763, which I believe is this one here. It's got the larger leads, if I'm not mistaken. I get my magnifier hood on again to see the fine print on this. Yeah, 1N4763. So that's the larger. It has a larger leads, thicker leads on this one. 1N4763 goes right down here in the bottom left corner of the board. A little bit of coaxing and it will go right down nice and tight. It's a good chance that this clock is going to end up in my shop here, so you'll see it in future videos. Okay, the next one is the 1N4148, which is going to be this one because it's the only other one that there aren't 3 of them here. These ones are the BAT46, these 3 here. They go over here. So the 4148, sorry, goes right here next to this resistor. And finally, the last 3. Which go over here on this edge of the board. And that has the diodes. So now we'll do the capacitors. The capacitors are, here we go. Let's get some of this scraps off the bench here. Put it on the floor, why not? It needs to be swept anyway. Okay, so we have down here in the corner, this is a 10 microfarad, 250 volt. Be this big one here. Polarity is critical on capacitors. The positive lead is marked with a plus. That's the longer of the two leads. So we'll mount that one. Next one over is 220 at, that would be this one here, 220 at 25 volts, which is this one here again. Positive is to the right, looking from the bottom of the board. It's marked with a plus. Next one over is 22 at 16 volts, which is 22 at 16, which is going to be this one here. Yeah, 22 at 16. And finally, 220 at 16, which is this one here. That one goes to that spot. Okay, that has the electrolytics mounted. Now we've got the smaller capacitors, the 2.2 nanofarads. Yeah, these are these two here. These two go one right in front of this 220, and the other one goes over here. These ones are not polarity sensitive, by the way. So they're marked with 222. We'll mount the 0.1s. There's a 10 nanofarad and there's a 0.1 microfarad. Now the 10 nanofarad is going to be this little one here. I think it should say 10 on it. It might not even have any markings. The other ones, the 0.1s, they'll have a 103 on them, and that is these ones here. So, or 104, sorry, 104. So here's the 0.1s. We'll mount the 0.1s. One of them goes right next to the 220 16 volt, which is right here. And the other one, it goes right next to it. So the 2.1s are there and there. And the last one is the 10 nanofarad, which goes over here. So that's the last of the ceramic capacitors mounted. As you can see, the kit is going together quite nicely, even though there's no. Well, I got some printed. I got some pictures, instruction pictures. I will say though that the instructions are a little easier to follow than some of the Chinese kits. Okay, that's got the capacitors. These are the this is what the manual looks like, right? So you get a picture, and then you get the location, so it's easy to figure out where things go from that. Okay, and then we're going to mount the transistors. Now there's they're MPS A42. There's a bunch of them. So the MPS A42s are going to be in this bag full of parts. MPSA42. They go in all these spots here. They go in the 4 at the back here, and these two, and the rest of the ones along here, and they only go in one way. They are keyed. Just put them all in. One last one here. Okay, so those are all the MPS A42s are mounted now. And now we'll solder them in. So at this point, if you're building this, you should have those components mounted. So now we'll just tack in all the transistors. Okay, that has these transistors mounted. That's the MPSA42s. Move on to the next page here, and now it's going to have me mount the MPSA92s, which are these 4 transistors here. Now these are different transistors than the other ones. They're packaged in a separate bag because they're a different polarity than the other transistors. MPSA92. These are going to be the anode drivers. The other ones were the cathode drivers that drive the 10 segments of the Nixie tubes. These are the anode drivers. So basically how it operates is that each tube is only operating 1/4 of the time. It switches between the 4 tubes. And these transistors switch between the 4 tubes. So depending on which segment's on, if this is a 1, and this is a 2, and this is a 3, and this is a 4, etc. If you wanted to have the time 1234, the first transistor would conduct along with this one for 1, and then the second one would conduct, and then the next number 2, and the third one would conduct, and if that was a 7, it would go to, or 5, it would go to the 5, and if the third one was a fourth one was a 9, that transistor would conduct, and the transistor for number 9 would conduct. That is how a multiplex display works. Similar to how a multiplex display works on a 7-segment display, except for in this case, there's 9 segments. It's a discrete readout. Actually 10 segments, 0 through 9. But a multiplexed 7-segment display works exactly the same. Except for each segment that's lit would be, each transistor for the segments that need to be lit would be on at the same time when the main driver for that digit were to go high. I think if I were to look at the schematic, I would see that the MPSA92s, these 4, are being driven by the other 4 that are directly below it. They're just reversing the polarity. So there'll be an NPN that's driving a PNP. Okay, that's got those transistors are now mounted. Oh, and then I have to also mount the 2N3906, which is one of these other transistors down here. 2N3906, yes, that goes right down here near the bottom of the board, right here. And there's another 2N3906 which goes over here. It's a voltage regulator at LM117.3.3. I think that's this one here. And this is an IRP 740. Yeah, IRP740. It goes right here. And the LM117 goes over here. With the tabs facing towards the edge of the board. Okay, next we're going to mount a couple of the IC sockets and get them ready to go. We have 3 ICs here, I believe. Yeah, 3. So we'll mount our sockets in the board here. It's nice to get a kit and have the IC sockets where the pins aren't all mangled like the last couple ones I've got where the pins have been all falling out of the sockets. I've had to put the pins back in and try to get them through the board. But unlike the last kit I ordered from Tindy, which was the Numatron, this one was packaged properly in a box. Got a crystal to mount as well. Crystal mounts right here. We are going to solder this crystal down to the board too, so I'm going to heat the pins up here just so that it'll lie flat. And then we're gonna put some solder onto the actual can to hold it down to the board. That way we don't have to worry about it getting bumped around and damaged. It's fused down to the board, so it'll keep it safe from any mechanical shock that would occur if it was floating free. We're going to put our inductor down here, our 220 microhenry coil. It goes right down right here. This is what generates the high voltage from the inverter that's on board. That'll be the driver transistor for it. This is what they call a buck converter, so it doesn't actually use a transformer, but what it does is it uses that inductor and it pulses it on and off and works on the magnetic field collapsing in the inductor to produce a higher voltage, which is then rectified and stored in the capacitor here. So a lot of these circuits use an inductor as opposed to using an actual transformer. I know where the power connector goes. I think it goes right down here, but where it probably goes in on the back side, I'm thinking. I think it goes in this way, like this. Probably goes in like that, I'm thinking, on the back side. That's not pictured here, so I'm just looking at the layout. It looks like, yeah, it goes in this way from the bottom. Power connector plugs in on the back like that. And you can see where it's been labeled. So we'll put that in and we'll solder it in from this side. Got a couple of buttons to set the time. Even got little caps to go on the switches. I believe this is where the battery goes in the front here. Yes, it is. I'm trying to figure out what this was here. This is for the backup battery, and it just goes in just like that. Again, it's not listed on the parts list. You just kind of have to guess. We're getting down to the wire here. It's almost time to install the pins for the sockets. I've got some LEDs for those that like to have the silly LEDs lighting up that you can put into the bottom of the tubes. It's got blue LEDs. So now we're going to mount the pins for the Nixie tubes. I'm going to do it the same way I did with the other ones. I'm going to put the pins on the base of the tube first. That way the tube can be set into the board and it'll get my alignment correct. So we're just going to put all the tubes pins on. We'll just use one tube initially. Kind of neat because with this design of tube, you can see how they've put these things together with all these little fine wires that they've used to connect each of the elements, each of the cathodes up to its own pin. In this particular tube, these are the ones that have got the backwards 5. So these were Soviet-made tubes, and basically to keep their costs down, rather than actually cut out a 5, they just used a 2 and they turned it upside down. So the 5 is an upside down 2. Okay, now we just have to mount the tubes here, and it'll show me which way to mount the thing. You got to mount it so that the digits are upright. Tells you which is the anode too. These are the anode pins here, the 4 anodes. So you can tell the anode pin because it's got a white insulator on it. That's going to be the anode that goes to the shield here. So the tubes with the pins, those go to the one marked A. Just like that. Now we'll put this in and we'll solder down these pins and do the same for the remaining tubes. We want to keep our solder time relatively short on these two, only a couple seconds each, because we don't want the heat to travel down the tube and possibly cause damage to the seal. So by keeping our solder time short, we will minimize the risk of damaging the actual tube itself. Okay, that's one tube in place. Two tubes mounted. Okay, that has my 4 tubes mounted. So now we have the two neon, the flashing dots in the middle to go on. There's 2 cups on here, you can see them. The large one is the large cylinder is the cathode. It says there's a small dot on the anode side, wherever that is. Oh yeah, there it is there. There's a little tiny dot. So the anode is marked on the board. I'll just put those down through here. Okay, I think that's pretty much everything. I just have to put the ICs in this thing now, and oh, I got these silly LEDs. We want to have the LEDs to light the tubes up so that they glow blue. Why does everybody like glowing blue tubes? Apparently everybody does like glowing blue tubes, so let's do that. Let's make these tubes glow blue. So we just bend them over like that and bring them down here and bend them to go through the bottom of the board. And of course we have to pay attention to our polarity. Now these are in the high voltage circuit, so you have to make sure that they are off the board a bit so that they don't touch anything. But they can go in just like that, a little bit of space between all the LEDs. That way you don't have to worry about short circuits. So we're just going to bend the leads at a 90-degree angle so that the diode can sit in there. We'll just mark where it's going to bend and then just bend these other ones here the same. Okay, that's the parts all done. I believe that's all the parts there are in this thing, other than the battery and the ICs that have to go in. So let's get the ICs out of their protective container. We'll mount the ICs. We've got an MSP430 G2553. It's going to go, it's the largest one. They are keyed. There's notches that show you which direction they go. The key goes towards the edge of the board here, the pin, number 1 pin. Okay, that's one. The next IC is a 4017, a CD4017. It also goes in the same direction. The keyway is on this side here. So the notch goes in this direction here. I don't like IC sockets. It makes it easy to bend the pins of the ICs. And the third one is this MC34063, I think it is, and it goes in. The pin 1 is facing this side of the board. The notch is on this side here where I'm pointing. So a little 8-pin dip. This is going to be the oscillator for the high voltage. Oops, this is why I don't like sockets, you see. It's easy to bend pins. He's even sent me a nice lithium battery. So I got the lithium cell here, and positive terminals that way, so we push the lithium cell in just like that. Now I need to find a power supply. It says it's 12 volts center tip positive. I'm sure I won't have a problem finding one of those. And it takes 1 amp. You got a power cord plugged in. Plug in power and see if this thing's going to do anything. Ah, it is lighting up. I got to turn some lights out in here. It's really bright. I'll kill some of these lights, and then we should be able to see the Nixie tubes, because they are glowing. says 1202. I can hear my menus. It's not as bright as I thought it would be. It's certainly 6, 7, 8, 2, 3, 4, 5, 6. So there's looks like there's 6 menus. Just gotta figure out what menu does what. First would be hour. Okay. So first thing is hour. The hour is 7. So then the next one over is gonna be the minute, 56. Third one's going to be 12 or 24 hour. You can see the settings there. Fourth one says 09. Oh, that's going to be the lights behind it. You can turn up and down the lights. There's right from none to full brightness. 5 is, I don't know what 5 does. 5 is cathode poisoning. Okay, no effect. 1 is slot machine, and 2 is display time for 2 seconds and off for 8 seconds. So that if we put it in 2, that display the time for 2 seconds and turn it off. So this is slot machine number 1, and the next one 6 is separator mode, off or display PMs, or there we go. There's the cathode poisoning to stop it. So separator mode off, 0 is off, 1 is display PM in 12-hour mode, and 2 is blink every second, and 3 is blink every second, blink twice when PM. So let's do that one. So that's option number 6. 0, 1, 2, 3. Okay. I guess we're not set for PM. So we'll do the hours mode here. Okay, 7. Okay. There we go. So there we go. Now it's flashing twice to show PM. Cool. Looks very neat. I'll turn it around and show you guys without electrocuting myself, because there's 170 volts on here, but there's what it looks like when it's running. I killed some of the lights in here. I say it's still very bright. There we go. There's what it looks like. Love it. 40. What did I say? What's 48 bucks? I don't think you're going to find a Nixie tube clock anywhere that's the price that this one is. Prop it up there so you guys can see it better on the camera. Fantastic. There you go. So if you like one of these, go to Tindy.com, I guess it is, and search Nixie tube clock. Guy's name is Rob G. Shipping was very quick. Again, the only thing is he won't ship outside of the United States, so you have to have a U.S. mailing address to have this thing sent to you. But what a wonderful little kit. I love it. It's just Nixie tubes. I just tell you, I love Nixie tubes. They just look so cool. And this is the Russian, the backwards 2 for the 5. So 759. I like it. I think my other one is nicer. My 6-digit one I think is nicer than this, but you know what? It was a couple $100. It was like $300 by the time I paid the exchange, because it was out of the UK, so it was in British pounds. By the time I got it here, it was a couple $100. I forget exactly the amount, but it was expensive. This is inexpensive, and it looks every bit as nice. Thanks for watching, and we'll catch you again real soon.